So here's a graph for this function f. As we can see here, as x approaching to infinity, the y value, the function value, is approaching to 1, getting closer and closer to 1. So we say that the limit of this function f is approaching to 1 as x approaching to infinity, as x approaching to positive infinity. Now, on the other side, when x approaching to negative infinity, we see that the function value is getting closer and closer to -2. So we say that the limit of the function as x approaching to negative infinity is equal to -2. Now, when you consider those end behavior of this function, when x go to infinity, this function approaching to 1, and we will say this horizontal line y equal to 1 is a horizontal asymptote. Now, when x approaching to negative infinity here, the approaching to -2, then we will say this horizontal line y -2 is another horizontal asymptote for this function. It's another horizontal asymptote for this graph. So this function here has two horizontal asymptotes here. Okay, so to find horizontal asymptote, basically we look at the end behavior, and we want to see what happens when x go to infinity. Does the function approach to a finite number? In this case, it approaches to this finite number 1. So y equal to 1 is a horizontal asymptote. Now, and then we also look at the other end, on this end over here. When x going to negative infinity, function value is getting closer and closer to -2. Here, I'm making a mistake. This is -2. So the function value is getting closer and closer to -2. So y equal to -2 is a horizontal asymptote. So horizontal asymptote in Chinese, we call that 水平渐近线. And here's a Spanish translation for that. Okay. Asymptote horizontal, isn't it? Okay. All right. So to find horizontal asymptote, basically we look at the end behavior at the left end and the right end. Does the function approaching to a finite number? Now, this second example here, here's a graph for this function f. Okay. We see on this end, as x going to infinity, the function value is getting closer and closer to 3 over here. So we say this horizontal line, y equal to 3 is a horizontal asymptote. Now you see over here, this horizontal asymptote, the function can actually cause it. Actually over here, it can cause it infinite many times. Okay. Number 3, in this example, we look at the end behavior of this function f. On this end, the function value doesn't approach to any finite number. However, on this end, we see that the function value is getting closer and closer to this number L. So we say this horizontal line, y equal to L, is a horizontal asymptote. So the formal definition for horizontal asymptote is this. The line y equal to L is called a horizontal asymptote of this curve y equal to f of x if either the function approaching to L when x goes to infinity, or the function approaching to L when x goes to negative infinity. So pay attention to this. Is when x goes to infinity or negative infinity. So basically you want to see what happened at the left end and the right end. Does the function approaching to a finite number? If it's approaching to a finite number L, then y equal to L is a horizontal asymptote. Now we call that this vertical line is a vertical asymptote if at least one-sided limit equal to infinity or negative infinity. So for example, in this case, in these 4 cases, the vertical line over here, you have at least one-sided limit equal infinity or negative infinity. You see this one, the left-hand limit is infinity, left-hand limit is negative infinity, right-hand limit is infinity, right-hand limit is negative infinity. So this vertical line here, we call that vertical asymptote. So you see the difference between horizontal asymptote and vertical asymptote? Basically, let's put them together and compare them. So to find horizontal asymptote, we're going to let x go to infinity or negative infinity and see if y approaching to a finite number. And for vertical asymptote, we let x go into a from the left side or the right side and see if the y value go to infinity or negative infinity. So that's how we find vertical asymptote. You see when you compare them, you kind of notice there's some similarity here. Over here, horizontal asymptote, x go to infinity or negative infinity. And for vertical asymptote, the y here go to infinity or negative infinity. Now, take a look at this example here. This is the function inward tangent of x. The graph of it, remember our function dance, okay? So the function dance for inward tangent, it goes like this. Kind of like a Tai Chi. It's kind of like a person playing Tai Chi, right? All right, so it's not the depth, okay? Okay, anyway, so this is the function dance move for inward tangent, and the graph look like this, okay? With this, when you see, so we want to see horizontal asymptote, so we look at this end and also this end. So as x going to infinity, we see that inward tangent getting closer and closer to power 2, and when x going to negative infinity, the function value getting closer and closer to negative power 2. So we have horizontal asymptote, y equal to power 2, and another horizontal asymptote, which is y equal to negative power 2. Notice that this is the y value. So y equal to power 2 and y equal to negative power 2. So we have two horizontal asymptotes. Next example. This time we're giving this graph, okay? Now from the graph over here, we look at the end behavior of the function. We want to see what happens when x going to negative infinity, okay, on this end, and when x going to positive infinity at this end. When x going to negative infinity on this end, we see the function value getting closer and closer to what number? It's 1, right? Okay, so getting closer and closer to this 1. So y equal to 1 is a horizontal asymptote. And look at the other end. When x going to positive infinity, we see the function value, it's getting closer and closer to 0, right? Getting closer and closer to this x-axis. So y is approaching to 0. So y equal to 0 is a horizontal asymptote. So we have two horizontal asymptotes by looking at the end behavior here and also the end behavior here. So to summarize it, to find horizontal asymptote, we first find the limit of the function as x going to infinity or negative infinity. So at this end and also at this end. So now we also want to see vertical asymptote. So this vertical line here, let's take a look at the left-hand limit. Looks like when x approaching to -3 from the left side, the function is going to keep on going up. So we say the infinite limit here is infinity. So x equal to -3 is a vertical asymptote here. So the y go to infinity. So this is a vertical asymptote. Similarly, when x approaching 2 over here from the left side, the function value, the function is keep on going, the function value keep on going down without boundary. So it go to negative infinity. So the left-hand limit here is equal to this infinite limit negative infinity. So this vertical line x equal to 2 is a vertical asymptote. Now notice that the left-hand infinite limit is negative infinity, but the right-hand infinite limit is positive infinity. But we only need to have a one-sided limit equal to either infinity or negative infinity. So in any case, this is a vertical asymptote. Now I'm going to give you a hint for this homework, okay? This will be a homework help. In your homework, you see this function. It is a rational function. In other case, it is a polynomial divided by polynomial. The domain for this function will be all real number except those numbers that cause 0 in the denominator. So the domain for this function is all real number x such that x does not equal to 1 or -3. Now, after you find the domain, now you can reduce it. Okay, so we can divide out this x plus 3. So leaving you with this simpler expression here. So this is called the reduced form of this function, but notice that this, you still have to keep this domain here because this is the original domain for the function. So how can we find a vertical asymptote for this function? So you will look at the reduced form of the function, which is this one, and you want to see when does the denominator equal 0? The denominator equals 0 when x equal to 1. So x equal to 1 is a vertical asymptote for this function. So when you have a rational function, you want to find vertical asymptote, you will reduce it, and then set the denominator equal 0. You find the vertical asymptote over here. Okay. Note that what happened here is, well, when x equals -3, the denominator also equals 0. Okay, in this original form. However, they got divided out. Okay, they got divided out. So it is not going to contribute to a vertical asymptote. In fact, it is going to be a gap. Okay, so when you graph this function, and you will take away the point that corresponding to the x coordinate equal -3 and make it a gap. Okay, so that will be a gap. Okay, so let's take a break.